Hey guys, it's Dr. McJunkin back for some more pre-calculus videos in week 2 of online learning. Today we're going to be looking at lesson 3, sample spaces and probability intro. This again goes along with section 9.3 in your textbook if you want to follow along and get some of the more examples there as well. First off, what I'm going to start with today is some definitions. I'm going to use a lot of words today, so I want to just make sure that we're on the same page of what they mean. So since we're going to be talking about probability, the first definition is any happening, this should be any, oh my goodness. Any happening for which the result is uncertain, I'm calling it an experiment. So probably a little bit different of definition of experiment than you have in science class. But for this, we're just going to say experiment is anything that we do where the result could be uncertain. We're not 100% sure something's going to happen, which is most things. The possible results of these experiments, I'm going to be using the word outcome for those. They're outcomes of the experiment. The set of all possible outcomes of an experiment, so all the different outcomes that could happen, is the sample space of the experiment. And so that is, oh my gosh, part of our lesson. We're going to be talking a lot about sample spaces today. And then a subcollection or a subset of a sample space is a certain event. Say we're flipping 2 coins and we want the event to be just like, do I get a heads? Do I get 2 heads in a row, etc. Okay, so let's talk about sample spaces before we start talking about calculating probabilities. So to find a sample space, I want to write down all the different things that could happen if I do these certain experiments. So for part A, we want to toss 1 coin. Okay, that should be easy. I'm going to use the big letter S for sample space, and I'm going to use curly brackets to say, like, these are the things that are inside my sample space. Okay, so if I toss 1 coin, there's only 2 options, unless it lands on the side, but we're not going to take that. So there's either heads, which I'm going to represent with just an H. So you can get a heads, or you could get tails. And those are the only 2 options. There are only 2 events in my sample space. There are only 2 different outcomes here. Great. For B, I want to toss 2 coins. It's going to be a little more tricky now. The first coin could be heads or tails. The second coin could be heads or tails. So let's write down all the different possibilities there. So both coins could be heads. So let's get HH, 2 heads on the coins. Both coins could be tails. Great. Here's where it gets a little confusing. There are 2 options now for 1 heads, 1 tails. The first coin could be heads and the second coin could be tails, or the first coin could be tails and the second coin could be heads. So these look a little bit, they look the same because you have 1 heads and 1 tails, but because the coins are different, these are different events here in my sample space. 2 different events, 2 different outcomes that could happen here. You'll be looking at what happens when you toss 3 coins. Ooh, how fun. Another more complex sample space will happen when we want to toss a coin twice and roll 1 6-sided die. So I'm tossing 2 different coins and I'm rolling a 6-sided die. So I'm going to again write down my sample space here, but there's going to be a lot of them. So I'm going to use some kind of notation to help me out. I know that when I toss 2 coins, I have 4 different options here. If I toss 2 coins, I can get any of these 4 options. We already wrote them down. So let's go ahead and write those down here. I can get heads, heads. I could get tails, tails. I could get heads, tails. Or I could get tails, heads. So those 4 things could be what happened with the coin, the 2 coins. If I roll a 6-sided die, there's 6 options, 1 through 6. So I could get heads, heads, and a 1. I could get heads, heads, and a 2. I could get heads, heads, and a 3. Heads, heads, and a 4, and so on for all of these here. So I get, for each combination of heads and tails for the 2 coins, I could get 1 through 6. For shorthand, I'm just going to use the notation here that, hey, the tails could also be 1 through 6. The heads tails could be 1 through 6. Heads tails 6. And the tails heads could be 1 through 6. So I have lots of different options here. 6 times 4, there's 24 different options here, 24 different outcomes in my sample space. Ooh, cool. So let's go ahead and talk about probability. I'm sure this will be a lot of review, hopefully, but maybe the notation will be a little bit different, so I kind of want to go over that a little bit here. So if an event E has some number of equally likely outcomes, which I'm going to say n of E, like the number of elements in E, and the sample space has some number of outcomes in it as well. In the last example we saw, there were 24. The probability of getting the event E is how many times or how many events, how many outcomes are there in the sample space of E, and how many times can you get the event E over how many total outcomes here in the sample space. Probabilities always range between 0 and 1, or sometimes people will say 0% to 100%. So if you do it decimals, between 0 and 1. If you like percentages, between 0% and 100%. So let's look at probabilities in terms of that definition up here using the NE and the SE, or sorry, the NE and the NS, and the probability of E here. So I'm going to use this formula down here a lot. So I'm going to toss 2 coins in part A, and I want the probability that both land heads up. Okay, so we again see that we're tossing 2 coins. We have that sample space. It was heads, heads, tails, tails, heads, tails, tails, heads. And the event that I specifically want is getting both heads up. Heads and heads. So the number of outcomes in event E is just 1. There's only one way to get double heads. The outcomes, the number in the sample space, the total number of outcomes in the sample space is 4. There are 4 different things that could happen. So 4 in my sample space. The probability of this event then is just the number of times I get the event versus over the number of outcomes in my sample space, which is just 1/4. Or if you want to put it as 0.25. For B, cards. We're drawing a random card from a standard deck of 52 different playing cards. What's the probability that it's an ace? I'm not going to write all these out because there's 52 different playing cards. I'm not going to write that out. So let's go ahead and see if we can, without writing them out, actually figure out how many events or how many outcomes are in event E, how many outcomes are in the sample space. Well, the last one that I just talked about, the sample space, is easy. There are 52 total cards, so there's 52 cards in the sample space. For event E, what I want is getting an ace. If you are not a card person, I have attached in this document, or attached on this assignment, a standard deck of playing cards so you can see all those with different things labeled. But if you play cards, or if you can easily Google this, how many aces are in a deck? Well, there's 4. There's the ace of clubs, the ace of spades, the ace of hearts, and the ace of diamonds. So there's 4 aces in the deck, and there's 52 total cards in the deck. So then my probability is pretty easy. It's just, again, the NE over NS, which is 4 over 52, which is 1/13. Let me move that up so you can see it better. So 4 over 52, I always reduce to the lowest fraction, and I usually work with fractions. If you want to work with decimals, you'll have to round to 3 decimal places. It's in the assignment. Okay, example 3. I'm tossing 2 6-sided dice, and I want to find the probability that the total of the 2 dice is 7. Okay, so to figure out how many different ways are there for me to get a total of 7 when I'm rolling 2 dice. So I like to go ahead and put, hey, here's my first die, Here's my second die. Let's write out the options. There's only 2 dice we're working with. We can probably write down all the options. So the first die could roll a 1 through 6, and the second die would have to be a 6 to give you a 7. If you roll a 2 on the first die, then the next one has to be a 5. We can keep going. 3 would have to give me a 4. I'm going to get down a little bit here. Great. 4, the next other one has to be a 3, 5, 2, and 6, and 1. So if I count here, there are 1, 2, 3, 4, 5, 6 ways to get the specific event that I want. There are 6 outcomes here to give me event E, which is rolling the die. Let me see if I can focus it a little bit better. Maybe a little bit better. The total die, the total of 2 die is 7. If I want the number of the sample space, well, I have 2 different die. The first die has 6 options. The second die has 6 options. And from the fundamental counting principle, there are then, if I have to multiply them together, there are then 36 total outcomes of rolling 2 die. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, etc. There are 36 different ways of doing that. So my probability is the division of the 2. 6 over 36, which reduces to 1/6 chance. So you have a 1/6 chance of getting a total of 7 on your die. Cool. Almost done. 2 more quick examples. This one should be very easy, just looking at a graph here. So, see if I can focus this a little bit better. I don't know why it's not focusing greatest. Oh, much better. Okay, so the figure shows the numbers of degree-granting post-secondary institutions in various regions of the United States in 2015. What is the probability that an institution selected at random is in one of the 3 southern regions? Okay, so we need to find the southern regions. And I want to figure out how many of institutions are in the southern regions. So here's a southern region, there's a southern region, there's a southern region. So the number of events or number of outcomes in the event one of the southern regions is the addition of all of these numbers here. So I should get, what's that, 858 plus 302 plus 451. That should add up to 1,611 in one of those 3 regions. The number of events in the sample space is the addition of those plus all the other ones, the New Englands, the East North Central, the West North Central, the Mountain, and the Pacific. If you add all of those up, you should get 4,622. So make sure you get that. So then the probability of getting one of those, selecting one of the institutions in the South region is the number of institutions there are in the South region, the ones that you want, divided by the total number of colleges, post-secondary institutions there are. This is about 0.349. And I rounded to 3 decimals just because that's what I'm going to be asking you to do on the quiz as well. So if you round to decimals, you can either put 1611 over 4622, or you can round to decimals, make sure you give me 3 decimal places like I did here. And lastly, the lottery. Who doesn't want to win the lottery, quit their job, and just buy whatever they want? So in Arizona's top pick game, a player chooses 6 different numbers from 1 to 44. So they're going to choose 6, and they have 1 through 44 as their options. And they have to be different numbers. So once they select 2, they can't select 2 again. So it has to be like 2, 41, 17, 16, you get it. They have to be different numbers. So if these 6 numbers match the 6 numbers drawn in any order, the player wins or shares the top prize. So what's the probability that you win if you buy 1 ticket? So I need 2 things: the number of outcomes of winning, and I need the number of events or outcomes in the sample space. Cool. The way I win is I have to match that number exactly. I have to match those 6 numbers in any order. But if I'm only buying one ticket, I only get one chance of it happening. I only get one chance that the 6 numbers I chose match the 6 numbers in the lottery. So that's kind of boring. But the number of the sample space is interesting here. So I need to choose 6 numbers out of 1 through 44, which is 44 different numbers. But the order doesn't matter. This is key. Order not mattering means I'm going to be working with a combination and not a permutation. So because it told me the order doesn't matter here, I'm going to take 44 numbers and I'm going to choose 6 of them. So it's a combination here to find the number of outcomes. 44 numbers, choose 6, doesn't matter which 6 or which order they're in, as long as I have those 6 numbers. So then the probability of this event happening is 1 over that 44 choose 6. And I'm going to use my calculator to figure out what 44 choose 6 is. 7,059,052. So your chances are 1 in 7,059,052. I'm going to leave it like this because the actual number is like 0.0000. It's tiny. This is a tiny chance that you win. So if you're playing the lottery, probably not a great idea. You're really not going to win. It might be fun to play the lottery, but you have a very, very tiny chance of winning. Cool. So I know I went through those a lot quickly, and there were a lot of examples. Feel free to watch the video again, pause at any time to help you with comprehension so you can take your own notes. If you've got any questions, I'll be online from 9:30 to 11:30, so I can answer your questions really quickly between those hours. I'll also have office hours between 2:45 and 3:45. Would love to see you come on by if you had any questions on the classwork. That's all I got. I'll see you next time for some more probability stuff. We're going to get into mutually exclusive events and unions. Have a good one. I'll see you next time. Bye, guys.